Hey guys, welcome to another video. Today's learning objective is factorizing quadratics in the form of that form and then including the difference of two squares, and the higher tier is kind of also factorizing quadratics with a coefficient is not 1, as in the case here, but I'll talk a little bit more about that in a second. As usual, feel free to skip any part of the video if you kind of think you know what's going on, if you've kind of covered this before and just want to go to the worked examples, for example. So there's going to be quite a few worked examples in this this kind of video because it's a bit of a longer one, but yeah, let's get into it. What's really important is that if you've kind of covered last video, it's going to be quite useful in this and kind of really understanding that. So to that end, if you can just kind of multiply, switch to a pen, if you multiply out x plus 4 and x plus 7, if you can tell me why that equals x squared plus 11x plus 28, for example. Just as a check if you kind of remember last video. So first off, let's talk about the learning objective in terms of definitions. Quadratics. What are quadratics? Well, remember how I talked about polynomials? Well, quadratics are a form of a polynomial where the highest term is an x squared term. So it'd be x squared plus some bx, so some number b, plus c, some constant c. And there can actually be an a in front of here. So remember I talked about coefficients as well. Coefficient being the number in front of the, say, the x squared term, or in front of the x term. So the higher tier stuff, you have to factorize this into a two binomials. You have to factorize this into two binomials. Kind of with this a being not 1 for higher tier, but if it's kind of foundation tier, this will always be 1. And then difference of two squares, I'll get into that in a second as well. Okay, so say we've got a question like we have to factorize the quadratic x squared plus 7x plus 10 into the form of a kind of a binomial form, i.e. into the form of x plus a and x plus b. Okay, so since we have to factorize it into this form, why don't we expand this side out and kind of see what happens. So if you expand this side out, we go x times x, x squared. We can do x times b, so plus bx, and then a times x, plus ax, and then plus ab. And then plus ab, which comes out to x squared plus a plus bx plus ab. Okay, well, if we look at the left hand side, let me actually write it out again, x squared plus 7x plus 10, and we look at the right hand side and kind of compare them. So look at the 7x term, right? The 7 is at 7x and there's a plus bx here, so that means that the kind of a plus b, if we look at this, a plus b must equal 7. And if we look at the AB term, AB equals 10. So if we want to get from this form into this form, we have to find two numbers, A and B, such that A plus B equals 7 and AB equals 10. And kind of the way you really do this is actually a bit of trial and error and kind of just guessing. Okay, so if AB equals 10, well, we know 10 can be, say, there's two numbers that, so if I want to have two numbers that equal 10, that multiply together equals 10, for example, I had 1 and 10, or I can have, for example, 5 and 2, and those are kind of it, right? Those are really the only two ones that are. But let's try a plus b equals, if a and b are 1 and 10, then a plus b is actually 11. So here, wrong color. 1 plus 10 equals 11, which does not equal 7, right? But if we try with 5 and 2, 5 plus 2 equals 7. So that works. So in our case, we can write x squared plus 7x plus 10 as x plus a. And in this case, a can be 5 or 2, it doesn't matter which way these go. So x plus 5, and then x plus 2. And that's really kind of all there is to it in factorizing quadratics. What you do is you think about two numbers which will add to give you the middle term. So two numbers which will add to give you this middle term, and then these two same numbers should multiply to give you this end term here. So let's try another one now and see how that goes. Okay. Ooh, wrong color pen. Back to black. So I've actually got this written down. Having x squared minus 4x minus 45. Okay, so we have to find two numbers such that they equal minus 4, that they add to equal minus 4, and they multiply to equal minus 45. So what I'll do is kind of, if this question comes up, if it was said, you know, factorize up here, on the side, what I'll do is I'll say a plus b equals minus 4, and then ab equals minus 45. And it's usually easier to think about which numbers multiply to give you this, rather than thinking what numbers add to give you minus 4, because kind of you can think of basically an infinite number of numbers that will add to give you minus 4, so you should think about kind of which numbers multiply to give you minus 45. Okay, so when it comes to a minus sign, we have to kind of think about this a bit more differently. If there's a minus sign, that means that kind of one of the numbers is positive and the other number is negative, because the only way we get a minus sign is we do say a positive number times by a negative number, because two positives together will give you a positive number, and two negatives together will give you a positive number as well. So one of these numbers has to be positive and another has to be negative. So what we can do first of all is just think about two numbers that will multiply to become 45. So 45, we can do obviously 45 and 1. We can also have, say, let's see, this can, okay, it's divisible by 5, so 5 and 9, and then 15 and 3, kind of rearranging from that. So if we times this one by 3, and then divide by 3, it's 15 and 3. And I think that's actually it. But one of these will be positive and one will be negative. So let's say we do try out with 45 and 1. So let's say it's a minus 45 and 1. Well, if we add them together, we get, what is that? Minus 44. And even if we kind of, if we swap it the other way around, if this is positive and 1 is negative, we'll get positive 44. So that doesn't work out. If we do 5 and 9, say it's minus 5, then we get 4. But if we go positive 5 and negative 9, then we get minus 4. And that's it. That's what we need. So we can factorize this. So remember, we'll be in the form of x plus a and x minus a, right? That's the form, sorry, x plus b, sorry. That's the form we're looking at. So in this case, a can be, say, plus 5, and b can be minus 5. So we'll go, which equals x plus 5, brackets, and then x plus minus 9, which is x plus 5, then x minus 9. And there it is. So this is kind of the process that you get to it. So I've got another one lined up here. Why don't you pause the video and kind of give this a go. Remember how we do it, kind of, we think about what, just write down a plus b equals what, and ab equals what on the side, for example. So just give the video a pause, give it a go. Okay, so the first thing to note here is actually, it's not an x this time around. It's just important to remember that the variable, doesn't always have to be x. It can change around, and it's really important not to be caught out by that. Okay, now let's consider this. We know a plus b equals the middle term, 7, and a times b equals 6. As usual, we'll start with this ab because there's fewer numbers that will multiply to kind of equal 6 and numbers that will add to give you 7. So 6. So let me change colors real quick. 6. Okay, so 6 can be, say, 6 and 1, of course. Or say 6 can be 3 and 2. And that's really it. Those are the only two numbers. So those are like, sorry, the only two pair of numbers that will give you it. Okay, now let's add these together. And since we know they're going to have to be both positive or both negative, so technically we could actually have, say, minus 6 and minus 1. Those multiply to give you 6, right? But since this is a positive number here, we know kind of two minuses, two negative numbers cannot add to somehow give you a positive number. So these numbers, we have to go with the positive options. Okay, let's add 6 plus 1. 6 plus 1 equals 7. And there we are. And we could have done 3 plus 2 equals 5. So it cannot be that, which does not equal 7. And if we were to do minus 6 minus 1, so adding those two, minus 6 plus minus 1 equals minus 7, which is not what we need. So we know A and B are 6 and 1. So let's write this out. So R, this time not X, R plus 6 and R plus 1. And that's it. So in terms of showing your working, important to kind of have this A plus B stuff here on the side and A plus B kind of like that. As you get better at this, you'll kind of be able to do this by inspection. You can kind of think of the numbers in your head and then be like, oh, I can think of two numbers that will multiply to 6. These are kind of the different types of numbers and the list of pairs of numbers, and be like, from those lists, I can mentally check that there's only one that works. If you do enough of these, you'll be able to kind of eventually spot them as well, because a lot of the time the questions repeat. So once you have that, you can kind of do it by inspection. But a lot of the time, it's quite important to show your working in terms of showing this, just to ensure you get the kind of the marks. There's also kind of a special case of these quadratics and factorizing these quadratics. For example, x squared minus 25 to factorize this quadratic. So in this case, we don't actually have a middle term, so we can actually write this as, but we can write this as, for example, x squared plus, say, 0 x plus, and then minus 25. So in this case, we've got a plus b equals 0, and ab equals minus 25. So well, we can just think of 25, and then we know one of these is going to be one of a or b is going to be positive and the other negative by the minus sign here. So we consider the positive case first, and then we can apply the minus signs as we need. So 25 is either 5 and 5, or 25 and 1. Okay, so let's try this out. So say it's positive 5 and minus 5. Well, that adds 5 minus 5. Well, that's 0, and that's our thing. That's the one we need. If we were to do the 25 and 1, we have minus 25 plus 1, which is 1 minus 25, which is minus 24. And if we were to flip it around with positive 25 and minus 1, would we get 25 minus 1, which is 24. So in this case, A and B are kind of, A is positive 5 and B is minus 5. So we can write this as, which is equal to x plus 5 and x minus 5. And this is actually a special case. It's called the difference of squares. And in this case, you can see that kind of you've got the square, you've got the constant term, the final term here being a square number, and there's a minus sign here. And what you get is that it will kind of generalize into this form here. So generally speaking, let me use actually a different color. So generally, if you've got something in the form of x squared minus a squared, that will factorize to x minus a and x plus a. And if you want to see kind of why, let's just expand that out. Well, if we multiply this out, we get x squared, so x squared like that, plus ax, and then minus ax, minus a squared from that. And since ax minus ax equals 0, we have x squared minus a squared. And so kind of this is why if we see something in this form of x squared minus a squared, we know it's the difference of two squares and can kind of just go to that. So let me give you an example, just kind of another one, and you can work through this one first. If you had x squared minus 49, how would you simplify that? Okay, so I hope you took a second to give that a go. But so first thing I do is I see this, I know 49 is a square number, so and I can see then it's in this form. So clearly, if a squared is 49, then a must be 7. So we have x plus 7 and then x minus 7. Remember, there's going to be a plus here and a minus here in order to get a minus 49. So that's the difference of two squares, which is a specific case which kind of the learning objective does mention, so it's quite important to know that. Okay, now for the higher tier stuff, there's actually we need to talk about when the coefficient of x squared, i.e. the number in front of x squared, is not 1. So, sorry, we had, I think before, x squared plus 7x plus 10. But if, say, for example, we had, say, I don't know, 12 here, there's actually a different method we use to get to where we need. And this is higher tier only. So if you're doing foundation, kind of, it's just that you only need to consider where the coefficient here is 1. Okay, so let's consider a few examples. The first example that we're going to talk about is minus x squared plus 5x plus 24. So in this case, the coefficient is minus 1 in front of x squared. So in these cases, what the general principle to do is you factorize the minus 1 out to get x squared minus 5x, minus 24. So all we've done is kind of factorize the minus 1 out. If we multiply the minus 1 back in, we get minus x squared. The minus, this will go to a plus, and that will go to a plus again. So that's all that we've done. And now we go back to our regular technique of kind of figuring out kind of how to factorize this. So we think, okay, so a plus b equals minus 5, ab equals minus 24. Okay, as usual, we'll start with this one. And since it's a minus here, we know one of the numbers is going to be positive, the other number is going to be negative. And in fact, because we know a plus b is minus 5, we know the kind of the bigger number in this case is going to be the negative one. So say kind of if we get, so we look at 24, we know 24 is 24, 1, 12, 2, and 6, 4. And then 3 and 8. Okay. We only need to, so when we, and now we have the minus 24 as well, right? But since we know this is a minus 5, and so a plus b, so is minus 5, that means kind of the bigger number is going to be the negative one. So say in this case, right, if we had, if 1 was the minus number here, right, we'd always get a positive number because 24 is bigger than 1. So if we do 24 minus 1, we'll get a positive number. So if we want to get negative from these, the bigger number has to be negative. So what we can do is just go through these and give the bigger number the negative sign, and then only consider those possible cases, which is a lot quicker than kind of considering both cases, like, you know, saying, oh, 24, minus 24 and 1, and then 24 and minus 1. So now if we add them up, back to, why not blue this time around? So if we add them up, so 24, 1, minus 24 plus 1 is minus 23, minus 12 plus 2, minus 10, minus 6 plus 4, minus 2, 3 minus 8, minus 5, and those are our two numbers. So the ones we have A as 3 and B as minus 8, for example. So we have minus out here, switch back to blend that back actually, so equals minus, so we have x plus 3, and then x minus 8. And if you ever kind of, you finish one of these and you're not sure, and you want to check if you've got the factorization right, just expand it out and check. So we leave the minus out here. We have x squared, and then minus 8x, plus 3x, minus 24. And then we can do the kind of the minus sign as well. We get x squared, plus 8x, minus 3x, plus 24. Ooh, sorry. Which equals x squared, plus 5x, plus 24, which is our original kind of thing. Oh, sorry, I forgot the minus there, which is the original thing. So therefore, this is our final answer. We can kind of leave it at that. You'd have this kind of as an aside thing, or maybe on the corner somewhere up here, but yeah, wherever. So that's just a quick way of checking. And this is the case when we have a minus sign in front of the coefficient is a minus 1, or even in a case, for example, if we go back to our original example, which was x, or first one even, x squared plus 7x plus 10, if we had something like 2x squared plus, oh, actually let me just write out, we had 2x squared plus 14x plus 20, well, we've just multiplied this by 2, right, to get there. So if we factor a 2 out, if you factor 2 out, we have x squared plus 7x plus 10, and then we've just got the same one as we did originally, so that becomes 2x plus 5, x plus 2, and we factorized it. And there we go. And if kind of sometimes you might want to put this, take the 2 inside one of the brackets, so you get 2x plus 10, and then x plus 2. So if you can note a common factor, whereby if you kind of take it out, you'll get into a form where there's the coefficient of x is 1. That's a good neat trick to do just to make your life easier. But now let's consider a case where you can't do that, and there's a different method you actually need to use. And this is called kind of splitting the middle term. And so this one here is 2x squared plus 9x plus 10. Okay, so this is our question, and we have to factorize, so I'll just write factorize. Okay, so clearly kind of we can't, if we factor a 2 out, this won't be a whole number anymore. The 9 will become 4.5, which kind of makes our lives a bit more difficult. So this time around, this is the method we use. I'll just tell you the method, and in a separate video I'll include kind of the proof and the intuition behind it. That's completely optional if you're kind of curious and want to figure out why this method works instead of just kind of believing me on it. It might help you out in terms of kind of just if you know kind of the intuition behind it, it will sometimes make your life a bit easier. But you definitely don't need to know it. So I'll tell you the method first. So before we were looking for numbers which kind of multiplied to this number here and then added to that coefficient there. This time around, what we do is we consider the coefficient in front of x squared, this number here, and the coefficient in front of the 10. And then we say AB is equal to this coefficient times that coefficient, so i.e. 10 times 2, 20, and we'll add to 9, and A plus B equals 9. That's what we do this time around. And we have to find the two numbers that can accomplish this. Okay, AB equals 20. So let's think about it. So we have 21, and then we have 10, 2, and we have 5, 4. 21 add to 21, and remember, since this is positive, we know, since both of these are positive, we only have to consider the positive pairs. So 10 plus 5, 15, 5 plus 4, 9. So those 5 plus 4, 9 is the one we need. So now what we do is there's actually kind of an extra step here. We leave it at the 2x squared there, so we go 2x squared. And then we split this middle term, the 9x, into 5x and 4x. So into 5x plus 5x plus 4x. Plus 10. Okay, and now we have to look at kind of these two numbers and these two numbers here. And we have to consider if they factorize. So clearly there's no common factors between 5 and 2. There is between 4 and 10, but if this one doesn't work, then we kind of have to, if either of these don't kind of factorize nicely, we actually have to swap them over. So it then goes to 2x squared plus 4x plus 5x plus 10. And now this actually kind of factorizes a bit. So there's a common factor of 2 here, and there's a common factor of 5. So both of these factorize neatly. So these are kind of the way we keep them, I guess. So we factorize out the 2x here. So there's a factor of, so 2x squared is 2x times x, and 4x is 2x times 2. So we can take the 2x out, and it becomes x, so there, plus 2. Just to check, 2x times x, 2x squared, and then 2x times 2 is 4x, and then plus, and again the 5 factorizes out here, x plus 2. And now, we've got two new terms, but both of these have a factor of x plus 2, as we can see. So we can factorize that out again, so we can get a factor of x plus 2 outside. And what's remaining in this kind of thing here is 2x plus 5. And there we go. So now we factored it into what we need. We can just write that, and that's our factorization done. So again, just to review real quick, there's a few steps there. First thing we do is we look at the coefficient of x squared and the constant term. multiply them together and say AB equals that. And then we look at this middle term, the coefficient of x, and say a plus b equals that. Then we find the two numbers which satisfy this condition. In this case, it was 5 and 4. We split the middle term accordingly, like that. We make sure that they the first two terms and the last two terms will factorize nicely and neatly. In our case, initially it didn't, so we had to swap them around. We swapped them around, and then we took out the common factor. We did that. Now we've done that, then there's kind of another guess common factor, this x plus 2 bracket, that we can factorize out of this whole expression to get this to be left with 2x plus 5. And then there we go, we factorized it. So as I said, there's going to be a proof of this in another video. I know when I was learning it, I was kind of a bit annoyed. I'm like, oh, why does this work? I mean, it does work, but it's quite interesting to learn how this works. So do check out that video if you're interested. Let's move on to another worked example, because I know that was a bit complex. So let me zoom out. There we are. So if I move. Okay, you need to factorize this. So I'll just write factorize. Factorize it. So take a moment to pause the video. Remember the steps we've done if you want to rewind perhaps and rewatch the kind of what we've just done, and give this question a shot. Okay, so let me rewrite this out. Ooh, wrong color pen again. Okay. 3t squared plus 34t plus 11. Okay, so remember we look at, say, this coefficient here, the 3 and the 11. And we say AB equals 3 times 11, 33. And we know kind of A plus B equals the middle term, the coefficient in front of the t. So A plus B equals 34. Okay, now we consider the numbers that work here. So again, both positive, makes life a bit easier. We only have to consider the positive pairs. 3t, okay. 33, so we have 33, 1. 33, 1, 11, 3. I think that's it. Okay. 33 plus 1 is 34. Our job done. We didn't even have to check the next one because this one works. Okay, let's split up 33, 1. And so we have to split this middle term into 33 and 1. So if we go black pen, we can go 3t squared plus 33t plus 1 plus t plus 11. Okay, so interestingly, in this case, if we did something like 3t squared plus t plus 33t plus 11, they both factorize. They factorize neatly in both cases. So in this case, kind of we'll have just t plus 1 here, and here we'll have 3 kind of. Sorry, that was kind of badly explained. And my point is kind of, since there's the factor of only 1 here, kind of this will factorize neatly with anything. Since kind of there's, I guess, 1t here, so it will factorize neatly with anything. So it works both ways. So you actually have to kind of, let's try it the wrong way first, and then we'll see why it doesn't work. So let's try it this way, 3t squared. So we can factorize the t out here. So we're left with 3t plus 1, and then 33t plus 11. So we take the 3 out. Sorry, we take the 11 out. We're left with 3t plus 1. So this was the right way. It works. Let's try it the other way. Let's try it this way. 3t. Okay, so we'll take the factor of 3t out. We're left with t plus 11 plus t plus 11. And lo and behold, both ways work out. So sometimes kind of there isn't even a wrong way. So, you know, if it factorizes both ways, you're happy, kind of, it's happy days, whatever. So when there's a 1 here, it's life's a bit easier. So this can factorize because there's a 1 here, right? So this will become t plus 11 into 3t plus 1, because there's a kind of a 1 here without you don't write it, but it's there. And same thing here, you have 3t plus 1, and then t plus 11. And you can see kind of this one here does equal that. So sometimes, as I say, it's kind of both ways will work out, and I guess life's a bit easier that way. So yeah, especially when there's a 1 year, just I guess celebrate. I don't know, but yeah, that was kind of definitely a bit of a longer video. There's a lot covered there. I know when I first kind of was introduced to this, it kind of took a while for me to wrap my head around it. So if you want to look for the proof, check out the next video I've done, kind of completely optional though. And also make sure you practice these kind of, the more you do this, the more kind of eventually you'll just look at one and you'll kind of know what it is instantly. And there won't even kind of be thought in your brain really. It will just pop into your brain of the answer if you do enough of these questions. And that if you get to that point, kind of you really understood it really well. So just kind of make sure you practice these questions. I know you expect me to say this every video now, but yeah. So I guess I'll see you in the next one.